Welcome back, Mr. Brown with you again. So for this video, we'll be going through some parts of vectors. So vectors is a very lengthy concept, but the basics of vectors is just the distance between the starting point and an ending point, whereby you follow directions. So meaning, if you are given a question like this, you are going to be getting arrows on it that will tell which direction you're supposed to travel. If you're supposed to be going in that direction, you'll keep the values as they are. If you're going in the opposite direction, it means you'll have to negate the values, making them negative or opposite of what they were. So that's the basics introduction of what vectors will entail. So here we have some questions. So this is from CSEC paper 2021. Now this question says, I would have paraphrased the starting point because of the amount of words. So it was, in essence, it was saying that this triangle shows the triangle OPQ, in which OP is equal to 3U, OQ is equal to V. Q is the midpoint of OR, and M is the midpoint of PQ. L is a point on OP such that OL is 2/3 of what OP is. And they would have given this exact sketch as it was. After that, they now said, write in terms of U and V an expression for A, L, M. So now, looking at it, you can only travel lines that have the arrows on until you are able to calculate a value. So for example, PQ, there is no arrow on, so that means you don't know what the value of PQ is as yet. So if you needed to move P to Q, you could not just write the answer. You would have to now go the path that you know, which has the arrows and has values. So you'd have to move from P to O, O to Q, because those sides have values and they have arrows. So in this case, you're moving from L to M, but what is it? M is the midpoint of PQ, but you don't know what is the length of PQ to take the midpoint out of it, since midpoint means half. So it first means that you must, in order to move to P to M, it means you need to find what the length of PQ is. So now they're asking you what is L to M. So what approach will you take? It means you will have to figure out what the midpoint of PQ is, and then you'd add what value you'd need to travel. So let's try that. Moving from L to M. So the normal path would be moving from L to P and then from P to M. But as I said, you need to know what PQ is so you can take half of it for your M. So let's figure out what PQ is. So first let's write PQ. So let's write PM is equal to PQ over 2. So that's what PM is. So let's figure out what PQ is. So PQ, moving from P to Q, traveling the path you know. You come all this way down, so that's a U, that's a U. That's 3 U's that you would have passed through. Now, the arrow is showing that you should be going up, but here you are coming down. So it means that PQ is equal to negative 3U, because it's coming down, plus, so let's continue the journey. Now you come across from O to Q, which is V. And as we said up here, that PM is equal to whatever PQ is divided by 2. Therefore, it means that PM is equal to all of this, so negative 3U plus V over 2. That's what PM is. Now let's figure out what LP is. So L to P, that's a U. So it means therefore LP is equal to U. Therefore it means that L to M is equal to what LP is here, which is U, plus the distance of P to M. And from this it shows us that it's equal to negative 3U plus V all over 2. That can be simplified, as you know, fractions can be simplified. So let's just simplify quickly. So denominator would be, the common denominator would be 2 or LCM. So this would have an imaginary 1 for its denominator. So we'll say 2 divided by 1 is 2. So that makes here become 2u. And then we write about this 3u plus v. And we simplify that there. So negative 2u minus 3u, that would give us negative u plus v all over 2. So that's the answer for that in a simplified way. So based on the score marks that would be allotted, you and the time frame that you're working with, there's a possibility that it's allowed to just stop in this line, u plus 3, negative 3u plus v all over 2. But because of how the questions are structured, where this now will ask you what LM and show that LM and R are collinear, it will require you to simplify it so you can see the collinearity property coming out. So let's now go to PR. Now PR again means moving from P to Q and then from Q to R. Now based on the question up top here, we already found what PQ is, because PQ is equal to this. So let's write it. So PR, if you want to move from P to R, you need to first move from P to Q, and then you add that distance of Q to R plus QR. Now PQ, we already have it up here, so that's negative 3u plus v. That's what PQ is. And then here we see that based on the information provided, it says that OQ is equal to V, but it's saying that Q is the midpoint of OR. So if this part is half of the line and it's V, it therefore means that this other side is also going to be V. So you can just put plus QR will be V, and you simplify it. So negative 3u plus V gives you 2v. And that would be what PR is, because u, v, you can't add those together. Now, the final question now says, show that LM and R are collinear. So the first thing you ask yourself, what does collinear means when you're dealing with vectors? So collinear in vectors means that one vector is a multiple of another vector. So meaning if this is one vector and you multiply it by a number and you get the answer, it means that those 2 points will be collinear. And it also, collinearity also means that something is lying on the same line. So if you should have a line, 1 point is here, call that A, 1 point is here, B, and 1 point is here, C, it means that all three must be on the same line for it to be collinear. And it means that the distance between A, B should be a multiple or a factor of what A to C is. So if you should be able to get AB and you multiply by a number, it should give you what A to C is, and they must all be lying on the same line. So now this question is asking you to show that L, M, and R are collinear. So how do you move from that worded question to prove collinearity? So what they're asking you to do is write it as a vector. To say L, M, so the line LM and the line MR, they must be multiple of each other. So you can write it in a form of this set. To say LM is equal to KMR. Now the K is in a K, just like when you're dealing with transformation, enlargement. K is a scalar factor. So you're basically saying that LM is a scalar factor, is equal to a scalar multiplied by, or a number multiplied by what MR is. So now you need to work out each piece. Now LM, you already worked it out over here. So we don't need to work that part out again. So we now need to work out what MR is, the distance of M to R. So now, here, working M to R, we already know what PQ is. Therefore, since PM is half of what PQ is, and PQ was here, PM is here, it means that MQ is equal to the same thing as PM. So we can just say, alright, so let's focus on MR. So MR is equal to MQ plus QR. We know from over here, based on the PQ, that MQ will be equal to negative 3U plus V over 2. And QR, based on here, we know that that part was equal to V. So let's simplify, because these don't look so common or similar. So let's simplify. So simplifying this, same thing, common denominator, 2. So let's work this out. So 2 into 2, you just write back everything on this as a 3U plus V plus. So remember, this would have a 1 underneath. So we say 2 divided by 1 is 2. And so we multiply this by 2. So you end up with 2V. And then you simplify your question further. So negative 3U, there's nothing else to add to it. So you have that back. Negative 3U plus V plus 2V, that gives you 3V. All over 2. So let's factorize this out, that it can look, because if we should take this as it is, this is saying U, negative U plus V over 2. It's not looking too close because you're seeing 3's in that. So let's simplify or factorize it. So we'll take the 3 outside because it's common. So this leaves us here with negative U plus, take off the 3 there, leaves you with V. All over 2. Now, if we should look here, so this is what MR is. So MR is basically saying 3 over 2, or 3 halves of negative U plus V. But here, let's take the LM, since we can have it over here. Write it as it is. So LM would be equal to half negative U plus V. So let's look at it. Because if we take the 2 off, it would be a half here, negative U plus V. So this is what this is from. Now this is saying 3 over 2. So all you did was to multiply this by 3. And you get this. So now we realize that because LM and R, they are assumed now to be on the same line. And these two answers, LM is equal to this, so you see the same number here, same variables here, same variables here. All that is different is the coefficient, the numerators, because this is 3 and this is 1. So it means that this line, MR, is 3 times the length of LM. Therefore, because these are the same and this is a scale factor, it has proven that these two lines are collinear, these 3 points rather, are collinear. So it means therefore if this was drawn accurately, drawn to scale, and you should get a ruler and draw from L to M to R, you get a perfectly straight line, and the distance between L and M is going to be a third of what L to R is, basically. So that's what it means to prove collinear. This is the intro to vectors. So hope this video would have helped or clarified some of the challenges with vectors. So tune in again another time when I'll explain other mathematical concepts.